This is number 13 on page 370. So with this kind of problem, we always want to deal with the denominator first. Okay, so I'm just going to reproduce the denominator here. I do want to show you a shortcut for this problem that will be of use to some of you who are comfortable with this kind of shortcut. We're told that x is greater than 3, so therefore you could pick any x term. I recommend picking the lowest x term that you can. That is an integer. You could literally just plug it in to the question and then plug it into the answer choices and see which yields the same answer that you got when you plugged in x equals 4. So let's try that. Okay, so plugging in, this gives us 1/6 plus, this I got just from plugging in 4 as x, plus 1 over 4 plus 3, which is 7. Okay, so now we just need to make a common denominator. So the easiest way to do that is just to multiply 6 times 7. So our common denominator is 6 times 7, which is 42. And then we have to express 1/6 as a fraction out of 42. So you ask yourself, how did I change this 6 into a 42? I multiplied times 7. So I have to do that on the top as well, because this means I'm creating an equivalent expression, because I'm really just essentially multiplying by 1, because I'm multiplying by 7/7. Okay, and so we have to do the same thing for the 1/7. Okay, so this yielded 7 here, and then now we need to make an equivalent expression for 1/7, so we multiply by 6. This gives us 6 out of 42. So this 6 here is coming from our equivalent expression. I would just take a moment to note what we did here. So notice that we have to multiply by 7, which is our term here, to create an equivalent expression with this first term. You'll see the same general pattern if you are using variables. And note that here we had to multiply by 6 to generate our numerator. Okay, so now we can combine these terms. So we have 13 out of 42. And let's not forget that this is actually, in the original expression, it's 1 divided by 13 divided by 42. When we divide by a fraction, this is the same as multiplying by the reciprocal. So I'm just going to do that up here. So that means we're multiplying 1 times the reciprocal, which just means we flip these. We flip the 13 and the 42. So that will give us 42 over 13. So that is what we are looking for when we look at the answer choices and plug in x is 4. So really, now we can just plug in x is 4 into the various answer choices. So I'm just going to go to the next page to give myself room to do that. Okay, and just recall that what we're looking for is 42 over 13. That's what we're trying to get. Okay, so if I look at A, if I plug in x equals 4, as we did originally, we get 2 times 4 plus 5 equals 13. So right away, we don't have this 42 in the numerator, and that's what we want. So we know we're done with A. A can't be right. We need 13 in the numerator. Denominator. We need it to be in the bottom, the denominator. Sorry, I misspoke. Okay, and in A, we got 13 as the numerator, so that's not cool. That doesn't work. Okay, notice that answer B has 2x plus 5 in the denominator, which is great because we already know that's 13. So now let's plug in 4 equals x and see if our numerator, the top number, is 42. Okay, so we get 4 squared plus 5 times 4 plus 6. So this gives us 16 plus 20 plus 6, and that gives us the 42. So our answer is B. You could check the other answers. It's pretty easy to get rid of C and D because C is 13 and D is just the 42. So it's actually quite easy to get rid of C and D and feel good about B. I would just double check that you actually did every step properly, particularly some issues that I see are people not multiplying by the reciprocal, so not flipping this. That's a common error. That would yield answer A. Another common error is to try to cancel at this stage. So it was really nice they did not include 1 as an answer, but I'd say that 1 is a common incorrect answer because people try to cancel these things. But you can't cancel when you have a binomial on top unless you can factor the same number out of every term. Okay, so that's one approach to that problem. I really like that approach. I'm also going to make a video about the algebraic approach.